Hello everybody, how are you? I welcome you back to Robust Robots. I am Q and this is the third video in our series to make our very first robot. Let's get into it. So welcome back to the channel. I hope you guys are doing alright. And this is the third video. So today we are going to reveal deeper into building electronic circuits. But you see, since there is lockdown, you can't go outside, and you can't get any electronic components like batteries. If you are out of batteries, you can't get them. So I figured out a way to still show you how you can make your electronic circuits. So let's get into it. So all you need to do is go to Chrome. So the people who have done electronic courses, or they might know this site. It's known as TINKERCAD. Just type in TINKERCAD and then you can go, and this is the site www.tinkercad.com, the first site. Once it loads, so I have logged in already. So once it loads, you can there would be a sign in somewhere over here. Then after you sign in, this will be the first page that you will be greeted with. So there is a lot of things in the site that you can do, like you see there is this thing, this you can create designs, you can create circuits, you can create code if you want, if you are interested in coding. And these are like the lessons. I guess once you join a class, you can access some of the lessons over here. You can create free, like all of these designs are free, so you can, it's a really great site for that. You can create a project here. So this, I'm going to just give a short introduction here. So this is all the stuff that you can see over here. Like this is 3D created, this model over here. Then all of this is 3D created. So you can, this is all other people who have done this. So if you are interested, then you can use, you can see some of these models, like a car. What is this? Happy birthday, TINKERCAD. Okay. So you can see all of this stuff. You can just click on them and then you can view them. You can see circuits over here. Like these circuits will be crazy. We are not going to go so deep into these. And then you can see codes. Like this is all done, I guess, using code. I have never explored the code blocks, so I don't know a lot about it. But you see there are some amazing creations over here. People are taking the CAD and a lot of it. There's a lot to learn through the gallery, so you can go to the official site of TINKERCAD blog. Then you can use, these are the tutorials that you can see. This is the 3D tutorial, you can see all the steps over here. Then you can, if you make a 3D model, you can print it, you can send it to them, they'll print it and they'll deliver it to you. But I don't think so they will be able to do it now because it's lockdown. So once you get back, you need to get back, you just need to click over the top left corner here, Autodesk TINKERCAD. It will take you back over here. So this is the circuits. So now if you have created a circuit, this is a blank one. So you can like click the gear sign there. And you can just have properties. You can change the name and stuff. Give a description. Then you can duplicate and move the project if you want. I'm gonna delete it because I don't need it. So now if you want to make a new circuit, you just click on create new circuit. So this is a reminder, guys, that see, I'm doing this as a hobby, not like a full-time thing. So my approach will be like spaced out a lot. I won't be doing regular ones because it's not because this sort of stuff takes a lot of time to think and to implement. So it takes a bit of time to record these. But if you want like if you want to get to know when I upload, you can just subscribe and then turn on the notifications. And while you're at it, you can also hit the like button. Okay, well, let's get into it. So once you click on create new circuit, it will bring you to this page. So it's a random generated page. You can see this is all random. So once you create a circuit, it will randomly give a name to this circuit. So this name does not make any sense, so click on that name, just place backspace, and you can just put any name that you want. I'm just going to put a trial one. After seconds it will upload, so you can see a bunch of things over here. You can see all the components over here. So I think, yeah, in the last video I explained all of these components like resistors, LEDs, buttons, switches, battery, breadboard, cells, motor, etc. So I might explain some of these on our way, so let's get into it. So the first one we are going to make is, so we are going to recreate the circuits from the second video. If you haven't watched it, go back and watch the whole series, like the first videos. Then we are going to revise the first video, like the circuits from the second video that we did on the breadboard. So let's get started. So first you need an LED. So if you remember, in the second video we made circuit using LEDs and breadboard, resistor and a battery. So we'll be recreating those just to get familiar with the layout and how the site works. So first you need to bring out an LED. So once you click that LED, it will highlight it with a blue outline. So you can see its name over here, it's just named 1. I'm going to keep it 1. So you can see it has various colors. I'm gonna let it be red because it looks good. Then you need to slide out a 9-volt battery, or you can bring out a cell, but we haven't really used that, so you don't want that. And if you want to delete, you can just press delete, or you can select the component, and then over top left corner you can see the delete. You can just delete that. Let's make out a battery. So it's horizontal. Now we need to rotate it. So click on the 9-volt battery, and then over the top left corner there is a rotate sign that you can use. So now we have got a 9-volt battery and an LED. So the red is positive and the black is negative. If you remember, this is our LED. Now let's connect the anode and the cathode. The LED legs are given as anode and cathode. So the bent leg is positive and the straight leg is negative. So you need to do like a cross connection. So how you need to do is just like press on the red box. Once you get near the anode, just press there. You'll see this green line. Then you can just press, and if you go near any of the points of the component, then it will highlight it, and then just press it again, and there you go, you have connected the positive and the positive. So cathode goes to the negative. So this will be a bit hard to understand because it's cross, but it's X. Now, if you are getting confused in what is connected to what, then you can delete one of the lines, and then over here this is the wire color that you can choose from various wire colors. Like if you want, this is cathode, this is negative, so you can press this. So you can even change the color of this wire, like red, it's anode to anode. So the black is negative, red is positive. So that now I will be using this because it is easier to see and understand. So once you have did the connections, you can go to, like there are various things like code, start simulation, export and share. So if you click on code, there's no programmable things over here because there is just an LED and a 9-volt battery connected together. So once you now if you want to see this, you just have to start the simulation. So if you see this, like I'll zoom in. Now there is a bursting sign over here. It indicates that the current is way too much to handle for the LED. So we saw that in the second video. So if you put your cursor on the burst sign, then it will say that current through the LED is 915 milliampere while absolute minimum is 20 ampere. That means that the current flowing through the LED is 915 milliampere while the LED can handle only current about 20 milliamperes. So ampere is how much current flows to a part of wire in a second. So it is the ampere is dependent upon charge and time. So the more charge and the more time, the higher the ampere, and vice versa. So if you did this like physically, then your LED is bursted, it will blow up. So now you need to click on stop simulation so that you can make necessary changes. So first of all, you need to delete the connections. Next, you need to bring out a resistor. So this is how a resistor looks. You can rotate every one of the components by clicking this. Now once you click on this resistor, you can see its properties. Now we have given name, there is 1 and the resistance is 1. Now here is the symbol or the unit that we use. So resistance is measured in ohms. So there are various values of it: pico ohm, nano ohm, micro ohm, milli ohm, kilo ohm, mega ohm, giga ohm. So this is just normal ohm. So to bring down the current flowing through the LED, we need to use an resistor. So this resistor, if you see here, the value is 1 kilo ohm. So you read it like that. So 1 and K ohm means kilo ohm, means 1000 ohms. So you need to join this to the positive of the LED. So if you want, like, you can just bring it close to the positive and it will automatically attach, and then you can just click on the terminal 1 and on the positive. So if you remember, resistor don't have a positive or a negative, so it won't matter if I join this like this or if I rotate it 180 degrees and join it like this. So it won't matter. Then now we don't need red, so this is a bit hard. So you might have, if you are comfortable with using only one color wire, you can use this. So the negative to negative and the positive to the positive. So we saw this in the second video. So now just start simulation, and there you go, the LED is light. So you can see the difference, like in the change, like the LED is lit up. So you can see the simulator time over here. You can even share your project to your friends who are on TINKERCAD or know how to use TINKERCAD. So this is our basic circuit. This is the first circuit that we created. So now let's include our breadboard. Breadboard takes a bit of time to load because it's very big. So I'm just gonna delete this so that you know. So I also explained the breadboard working in the last video, so you can go and check that out. So as you can see, this is the first section, this is the third section, this is the fourth section, and this is the fifth section. Oh sorry, first, second, third and fourth section, sorry about that. So if you put your cursor on the top row, you can see that all of green circles around every hole. So it indicates that all those holes are connected to each other, And the same with this, the second row. You can go over here and you can check all of the connections, like they are not connected. Yeah, both of the all four sections are connected in different ways, like the first and the fourth sections are connected in same ways, and the third and the second sections are connected in similar ways. So let's use this. So we have been given that the negative sign and the positive sign, so it's better to use positive and negative. Breadboard doesn't have positive and negative, it's just for a reference. So bring out a 9-volt battery. If you want, you can zoom out a bit. I'm gonna rotate this, and as they have said, positive to positive and negative to negative, it's better if you do it like this, or else you're gonna have to make cross connection. So if you just drag the breadboard closer to, or drag the battery to the closer to the holes, it will automatically join itself. There you go, it has joined, and now the whole top row is negative while the whole bottom row is positive. And now you need a resistor. Check the value every time because you don't want your LED to blow up. Now you need LED. So we'll just create the first one, first resistor, first circuit again. So the LED goes into the resistor goes into the positive socket. Like if you go close, then you can see a small square appearing where it is connected. So if the square appears here above, then it's connected in the negative row, which we don't want. So we need to connect it into the positive row. Then connect the positive of LED to the terminal 2. We don't need black right now. I'm just going to change it to red. So anode to terminal 2, that's positive done, and it's connected right over here. So the resistor is connected to this anode and over here the positive side. Then the cathode, you can insert in any holes, like if you want, change the color. If you want, you can connect it over here, it won't matter. If you want, you can connect it over here again, it won't matter. You can connect in all the above holes or the sockets. So I'm just going to connect it beside the battery, beside the resistor. So this is our connection done. So the negative and the positive. So let's start the simulation, and there we go. The LED has lit up. It is really easy to manage all of this using TINKERCAD, because it really simplifies all the circuits. Let's just stop the simulation. I'm gonna arrange it neatly. Now you can see it a bit more better. So if you want, you can look at the last video, and I have showed some symbols of how they are represented. See, there is no code because there is nothing to program. So now let's use another component that you are going to see. So we will be using switches today. So this is a button switch, push button, and this is a slide switch. So we'll be using this today. Now since you have revised everything, we'll just delete everything. You might want to keep the breadboard. For deleting, you might just select a component and press delete on your keyboard. So first we'll make a circuit using the slide switch. So right now we'll not do it with the breadboard, but we'll use it normally. So drag out the basic components, which is LED, resistor, and the 9-volt battery. So if you are comfortable with rotating it, you can rotate. I will rotate it so that you understand this better. Or else we will use this button, because the slide switch can handle over 2 connections, and this will be able to handle only one. So let's go. So now you need to connect this in a straight way. Connect this here. If you see here, they gave the names such as terminal 1A, terminal 2A. That's not necessary. You can so disconnect this. Now through the wire, now the positive is over here, so above the positive leg, extend this wire to the anode. Again it will be a cross connection, and then connect the cathode here, but we need a resistor, so we are going to cut that out. Just join the resistor and then make the connection. Just gonna switch on black, change the color, so you can select and then you can also change the color. Start simulation. Once we press the switch, the LED turns off. You can see. So this is one type of circuit where once you press the switch, the LED turns off. So this will be one of the circuits using push button. You can try this if you have the components. Now let's use a breadboard. Let's try using a breadboard. So let's keep it over here. Let's keep this circuit for reference and drag out a breadboard. Then I'm going to put battery, a resistor and an LED. So connect those 2 points, positive to positive and negative to negative on the breadboard. Breadboard doesn't have a positive and negative again, and a push button. So again, terminal 2, so terminal 1A is connected to the positive of the breadboard, and this to the negative. Oh, I need to connect the resistor too. Keep on forgetting it. Okay, that's done. So black is negative, red is positive. So make sure that you connect it and not leave it floating, otherwise it won't work. Now anode positive. So let me change the wire color. There you go. Now this is the same circuit, just there is addition of breadboard over here. So let's see if this works. Yes, it does work, and the button also works. So this is one of the circuit that you can try using the breadboard. It's really easy to so once you make a change over here, you will see that it says all changes saved. So you might, before closing the screen, you might want to wait till all the changes have been saved. So this is the first circuit. I'm gonna leave it like this. If I can share, then maybe I will try and give you the link of this same in the description. I'll try and do my best to share this. So now this is saved. Now let's just go back and make another one with the slide switch. So now you can just go to properties, and if I want to change the name, so I can just go then back, and then you can say same slide switch. So that's it. So it is in slide switch. So now you need to bring out the basic components, a resistor, slide switch, don't bring out the push button. It's about to do that. And a breadboard. No, we'll remove the breadboard later. Just let's understand how this light switch works. So if you look at this closely, a slide, this is a slide switch. So you see it change. Now this is the top button that changes. Now if it's over terminal 1 and common, so this is a common part, and the terminal 2. So if it's between terminal 1 and common, these white strips, then the circuit connected between these 2 points is completed, and if it is in common and terminal 2, then the circuit connected between the common and terminal 2 is switched on. So that's how it works. So basically this small thing can hold 2 circuits, means it can power 2 circuits with a flick. So let's see. Now first, as usual, you need to connect the positive and negatives over here. So usually I connect the negative to the common, change the color, and the positive to the terminal 1. I change the color again. Keep on forgetting. Then all you need to do is join the resistor again and keep a track on what the resistance is. You don't want it to be a different one. So then terminal 1 connects to here. So just connect them again, and then the negative goes to the common. So once you can see, this is a bit confusing, but because of the change in color you might understand what I have done over here. Sorry for that. Or if you want to simplify, you can just go straight down, click, and then you can change the direction of the wire. So now you can align them. So now this is a circuit. So let's start the simulation. It switches off, on, off, on, off. That is it. So now let's try this using the breadboard. Now this is our breadboard. Let's bring out the resistor, the LED, the slide switch, and the battery. So connected. We need to connect the common to the negative, terminal 1 to the positive. Then the resistor goes into place. That's it. We start the simulation, and it's complete. Now you see I have done a very weird mistake over here. If you spotted it, very good. So basically I connected this point over to the negative. You need to connect it over here. So now let's start the simulation. It works. The LED is lighting up. So this is about the switch. So you can try these circuits in TINKERCAD, and if it is possible for me, I will share the links so that you can try, you can see them, and then you can make them on your own. So I'll be seeing you guys in the next video. Hope you had fun today. Hope you learned something new. Thank you. But please don't forget to subscribe, like, and share this, because you see I just do this for a hobby, and you can share this with your friends, those who are interested. It will be really nice. And if you have any doubts, post them in the comments. I will try and solve them if it's my it fits in what I know. So see you guys next time. Thank you. Bye.